Here is our 15-year-old Toyota Camry. Well maintained, well looked after, sprayed for rust each year. Well, take a look at this. Let's pull this back. So look down here, look at this. You see that? Solid here, but this entire thing, and I've seen this on other Camrys of this vintage. Let's see if we can fix it. I have the vehicle backed up on ramps just to give me a little more access to the underside. I start by removing the rear mud flaps. 2 screws, 2 into the well wall and 1 underneath. There we go. There we go. Okay. All right. Whew. On a 2010 Toyota Camry, the rear bumper cover is typically held on by a combination of bolts, screws, and plastic clips. We first start by removing the single bolt at each wheel, well hidden behind the fender liner. They leave a small hole for you to access it. A Phillips screwdriver will work here, or if it's fairly well rusted, maybe use a 10mm socket. Next, crawl under the rear bumper and remove 1 screw, securing the bottom edge of the bumper cover to the splash shield or underbody. Next, open up the screw cover using a flat blade screwdriver. There are 2 of these, 1 on each side. They are visible once the trunk lid is open. Gently pull the bumper outward, starting with the side. This will gently release the bumper from its clips. Nothing to that. So with the cosmetic bumper removed, we can now get a good look at the extents of the rust on the back end here. So there's 2 skins here. There's a skin here on the outside, and then there's the trunk skin behind it. And the nice thing is they're basically flat. So I'm just going to cut them out and replace them with some fresh metal. So having said that, we're going to take this bumper off next, but let's take a look in behind here. And the good news here, the mounting points of the bumper are solid. They're into steel. There's no rust there. 2 locations there. It's the skin between. There you go. This one here, that's the liner on the inside of the trunk, and rusted on the outside is the outer wall right there. So I'm gonna get this bumper out of the way. Never taken one of those off before, but it's probably not too difficult. And I'll probably drop the hitch. And we're not using that thing anyway. We used to carry bicycles on it, but probably pull that off and not return it. So that's next. Here I'm adding a little penetrating oil to give a fighting chance with the rusty bolts. I'll let this sit for 24 hours before I try to remove them. To remove the bumper, I made sure to use a 6-sided socket. These old bolts are rusty, and I want to minimize the chance of spinning. Okay, this one is slipping. On 2 of the bolts, they were seized. I used a chisel and vice grips and eventually got them free. This part I'm removing is called the rear bumper impact absorber, aka the energy absorber. It functions as a cushion, absorbing low-speed impacts and preventing damage from minor bumps. It sits between the bumper cover and the metal reinforcement bar, helping distribute force and protect structural components. I'm not reusing any of this hardware. I'll go to Ottawa Fastener and get some new hardware. 6 nuts hold the rear aluminum bumper on. Nothing really to add here, so I'll just jump ahead. Wow, that is a pretty serious piece of metal. Get a good look in there. So I was working on removing this rusty hitch, and take a look at this. Pittsburgh tools, including sockets, are a Harbor Freight house brand. Most Pittsburgh tools are manufactured in China, although some may come from other countries like Taiwan. These tools are typically made to be affordable and not considered professional grade in terms of durability. No kidding. So anytime you have a stuck bolt, you try everything. Here I'm trying heat. Didn't work. Next I used a cutoff wheel and removed the exposed bolt, thinking that would somehow help. Then I tried drilling out the bolt. This was going to take forever. After all, I have 6 bolts to do. I think I'll run out of drill bits before I'm done. As I depleted my drill set, I figured I would take a break with this bolt and try removing one of the larger bolts that connect to the bottom of the vehicle. This one actually worked. What I didn't know was, although the nut came off, the bar was firmly rusted in place and would not release from the body. I'll find this out at the end. Oh. 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 Holy crap. Oh. God, I wish it would break. Yeah. All right. It broke. Oh. So back to the rear bolts. Nope, just spinning. By this point, I have clearly demonstrated that these bolts are not coming off. I needed to cut them off. Now, if I had a cutting torch, this would have been finished in a few minutes. I then realized that it was easier just to cut the very thin body panel away rather than cutting through the 1/2 inch steel of the hitch. So that's what I did. Come on, what's holding it on? Oh, nothing. Let's get it off. Awesome. Okay, other side. Let's see what's holding on over here. As I mentioned earlier, although the bolts have been removed, the underside is still firmly rusted in place. Well, you didn't get to see it fall on top of me here. I had, where am I here? It was rusted on there really good. So I've been working on that the last half an hour, grinding, whatever. Anyway, it is off. And now I've got a really good look. Let's change hands here. Now I've got a really good look. 2 simple layers, very simple repair. I'm going to, let's back up a bit with the camera. I'm going to be grinding some of this back. Very likely it'll be cut back all the way along here, straight down, place one piece there. I'll cut that out of the way, and then this piece here will be, again, completely a flat piece. Good metal right here, and rotten right there. So we'll either weld or rivet on the new piece. But that's taken me a little while to get down to this. What's really nice is this is the only part that's deteriorated. It's good metal right there. And take a break, have a shower, clean up this entire mess. Start fresh tomorrow. Okay, so we're inside the trunk, and I've cleaned up outside. I want to now remove this piece of plastic. I have no idea how it comes out, but let's figure this out together. First off, there looks to be like a grocery bag tying hook here. And I noticed that if you just push on the center of it, it seems to, yeah, there we go. It just seems to pop out. So let's take a look at that. Okay, and there'd be one on the other side over here. Yeah, that was easy. And I don't know about the rest. I think I'm just gonna pull on it a bit and see what happens. You can see there's a, looks like there's a fastener here and maybe one down there. Don't want to break it. I don't see any screws though. Wonder if I should just pull up, or yeah, let me put this light down here for a minute. And gently pull up. Okay. Well, we either broke it or we pulled it out. I think we pulled it out. All right, so now that we've got it out, we can see how it's held in. And you can see these little plastic clips. So looks like I'm missing 1, 2, 3, 4. Just one right here. Got to pop that one back in, and the whole thing will just... Oh, it's right here. All right, so if you look here, where my hand is, this is actually oil that I've sprayed in here. The metal is good, down to about here. So I have good access to everything now. I'm going to start with a wire brush in the end of a drill and on the outside, and I want to see how far I have to go to get to good metal. The first thing I started with was a wire brush in the end of an electric drill. In many areas it was clear where I was going to cut the metal back to, but in other areas I wanted to remove the paint and rust to see exactly how far back I needed to go. The grinder with a cutoff wheel did an excellent job cutting through the 18 gauge steel. It's amazing how quickly it starts to look better. With the outer skin cut away, I now have better access to the inside skin. Like the outer wall, I'm now marking and cutting the inner wall to remove the rusted metal. This is looking really good. It's amazing when you get down to good metal. It is so easy to be overwhelmed by the appearance of rust in non-structural areas, yet it is a very straightforward repair that will last for years. I'm not gonna, oh, it's pretty soft. Look at this, Lynn. Oh, it's pretty soft. Here I'm using Cleco clamps. A Cleco clamp is a temporary fastener used to hold sheets of metal together during fabrication, especially in automotive, aviation, and metalworking. It's part of a system that includes the Cleco fastener and Cleco pliers. See, that's tightening up? Okay. And now put some more clamps in here. There we go. So I'll probably cut it off, probably somewhere right about here. And on this side, I don't think I need to go much past, maybe right in here. I'll probably cut it about there, cut all this off. And then I'm going to mark the center of these bends. There's a corner there, corner here.
Here I'm using a rivet fan spacer. It automatically divides a distance into equal spaces for making or drilling rivet holes. Next, I'm cutting relief slots around those areas in the metal that will be bending, only halfway through the steel. This will make more sense in a minute. Over to the bending brake to turn this steel into an L angle.
Oh. Okay, actually I'll do the rest with a hammer. Okay, I'm going to call that done.
We are a little further along here, currently in the process of forming this steel to the spare tire tub dimensions.
Okay, here's the piece. Took a little while, a little bit of tapping, and but it's now ready to go in.
We're working with clecos, which are temporary fasteners that hold parts together before riveting, bolting, or welding. I'm using a cardboard box as a template, and I'm using a black marker to trace the outline of the spare tire hub. I'm using a cleco clamp to hold the cardboard in place. With the template finished, I trace the template onto the 18 gauge steel and then cut out the steel. Next, back to the bending brake to form my new piece.
Yeah, I think it's pretty good. So I'm a little bit past 90 there. Not too bad.
Whoa.
Yeah. I'm going to call that good. That's pretty good. All right, let's just take a look here. I think I'm that way. Okay.
Two different sizes are being used here. The pilot holes were done with a number 40 drill bit, which is 3/32 of an inch, and silver clecos fit those holes. The copper or bronze clecos are 1/8 inch clecos and are standard for auto body panels, mild steel, and general fabrication.
Oh, that is really cool. All the rust is gone. All brand new steel. Wow.
Here's the template I made for our last piece, the outer skin. I'm using a bevel gauge to capture the angle from the cardboard template. Later, when I form the steel on the bending brake, I'll use this same bevel to transfer the correct angle and ensure the fit is accurate. Once again, I trace the template onto the steel and then cut the steel out. Back at the bending brake, Time to use the bevel to transfer that angle and get the steel shaped just right. Watch closely. For the second bend, my goal is to get this surface perfectly parallel to the first one.
Well, this is a great place to be. I've got all of the manufacturing done. And let's just show you this real close. It is super strong. There's the outer skin attached to the, I don't know, the wheel well, whatever it's called, spare tire holder. And all of this is 18 gauge. It feels a little bit thicker than what Toyota's using. The reading I was showing said that they're using either 18 or 20, but I'm using 18 for the repair. Anyway, this is super solid, no more rust. Next thing to do is to take all of this apart and deburr each hole. And what's next? Probably use a little bit of acetone to clean it up. Then I'll prime it, and then after it's riveted in place, I'll use some seam sealer and then probably some black paint or something like that to finish it up.
After drilling, it's important to deburr the holes. This removes sharp edges and rough burrs, which keeps the metal strong, helps rivets fit properly, and prevents damage or rust down the line. When deburring with an oversized drill bit, like I'm doing here, don't apply pressure. Just a quick spin is enough to clean up the burrs. I followed up with 100 grit sandpaper to clean off the surface rust and create a good surface for primer to adhere to. Now, acetone is the preferred product for preparing metal before primer. I didn't have any on hand, and I wasn't keen on spending $50 on a can of it, so I used Varsol instead. Now, that works fine, but you do have to follow up by cleaning with soap and water to remove any residue. Here's some 19-year-old zinc self-etching primer, and now it's going to get used on a 15-year-old Camry. Pretty fitting, right? Look at the price, $7.25. It's now $37.50 at Aircraft Spruce. Self-etching primer is specifically designed for bare metal surfaces like the 18 gauge steel I'm using in this repair. It contains acid that etches the metal surface slightly and creates strong chemical bond, while also laying down a primer coat that promotes paint adhesion and prevents rust. As you can see, I also applied the self-etching primer to the old metal to make sure it's properly sealed. Time to assemble.
Just going to take a minute here to talk about rivets. What I'm going to be using today is a closed end blind rivet. It's made from aluminum and often used in aircraft and automotive where sealing and strength are critical. So let's get a closer look at that. This is a closed rivet here. This is an open rivet. We'll talk about that in a second. So when installing a rivet, if you've never done that, this part here is called, let's put this down. This part here is called a mandrel. And as you pull it out, it pulls this backside in and squeezes it and becomes a permanent fixture. Now with a closed rivet, you end up with a sealed unit. No moisture can get through it. Where with an open rivet, a common rivet that you'd pick up at Canadian Tire, quite a bit cheaper, that kind of thing. This is kind of like a hollow tube, and yes, the mandrel does the same thing, but this piece can break off and it can fall out, it might leave a small hole or whatever. There's nothing wrong with these, but they don't provide the same kind of seal that you would get from a closed rivet. This is one piece, that's another. On this one here, this is one piece and that's another, but there's a hole on the end and you can end up with moisture getting through. Now I'm going to be using mostly this today, but you can use these as well. Well, they're common, they're a cheaper version. The mandrel breaks off and is partially exposed, or it can fall out. It's less water resistant. It's not ideal for a sealed environment like inside the trunk or exposed to road splash. So, however, I've got a little bit more reach on this one. This is something I already own. I'll probably use a couple of these to do today, but in that event, if I do end up using them, I need to make sure they're sealed. So even if I'm using this one, this is aluminum and the metal is steel. So I am putting an aluminum rivet into a steel sheet. While this is commonly done, it can lead to corrosion. So it's important that you use a primer with zinc. And of course, I've already done that. That's just one more layer protecting between the steel and the aluminum is the zinc coating. And the last thing you need to do, whether you're using either of these, is you want to make sure you use a seam sealer when you're finished. So I will be using mostly these today, but I will use a couple open because I've got longer reach, and I'll just make sure I use a good seam sealer on it when I'm done to make sure that no moisture can come into the vehicle.
During the assembly, you'll see me use two different riveting tools. First, this is a hand riveter, which lets me get into tight spots. Now I could use it for the whole job, but it can get tiring on my hands since it's manual. Later, I'll switch to a pneumatic rivet gun connected to my air compressor. Just 1 or 2 clicks on the trigger and the rivet is set. I gotta say, Clecos are awesome. People tease me all the time because I end up using them on almost every project. But hey, they're just that handy and super cool. Okay, this is seam sealer. Automakers make extensive use of seam sealer throughout a vehicle. It's applied anywhere two metal panels join, like floor pans or trunk seams or rocker panels. It's used to keep out moisture, dust, and road salt. Seam sealer helps prevent rust, reduces noise and vibration, and even adds some structural integrity. It's one of those behind-the-scene materials that plays a big role in how long our vehicles hold up. This is the last panel. Fabrication and assembly is now done. Here I'm applying the seam sealer on the inside of the trunk. Same to the outside, ensuring that all seams as well as the rivet heads are covered in seam sealer. This job took about a 1.5 tubes of seam sealer. I was quite liberal with it. Just off camera, I also applied the seam sealer to the underside all along our new joint. Later, I took the car through a car wash that includes a high-pressure underbody rinse, and the trunk stayed completely dry. So this seal is doing its job. This is asphalt undercoating, $15.99 at Canadian Tire. It's a unique product made from 100% asphalt, designed to effectively repel water and moisture. The substance is intended for primary use on inner panels, door frames, trunk areas, and floor pans where moisture concentration is high. Here I'm installing the reinforcement beam, or bumper. I used mostly new hardware during reinstallation. Next, it's the energy absorber or impact absorber.
So I'm thinking we do the back first. Yeah. So you can see this here. Looks like it clips in here. I think that's probably okay. I'm going to just give this a tap here and see if it sort of pops in or not. It looks like it's got to go this way a little bit. Something like that. And what's happening here? Has to go above this, like that. Ooh. Oh, look at this. let's get these.
I haven't done anything with this side.
No, it's just clipping in.
I haven't done anything.
Yeah, no, I've got this top part here clipped. I'll do that in a second. Let's put these two in. Wow, that's looking pretty car-ish.
Yeah.
Again, using new hardware. I chucked the rusty stuff out.
Okay, look at these little clips here. Oh, they're lining up perfectly. Look at that. So I got one screw to put in there, one down here. There. Okay. The next one's going to be tough because it's tires in the way. Let's see, one of these. See if I can get it going, or if I have to remove the tire. Can I go? I think I got lucky. That's it.
Here's more of that asphalt undercoating. I like this stuff. I'll use it again.
Well, that's pretty cool. These are our grocery grabbers. One and two.
This was such a rewarding repair. All in, it took me about 3 days of part-time work and about $130. That's it. Hey, thanks for watching. I hope you found this useful. Cheers.